Pre-lecture video number 2, Dimensional Analysis. Conversion factors allow us to change equations into useful fractions that help us to convert one set of units to another. Applying this to problem solving is how we achieve dimensional analysis, where we keep track of units to guide us to the desired final units. Even in the absence of a formula, you can sometimes identify how and where units should be introduced and or canceled out as your main guide to a problem. This approach will often help when you deal with units with which you're not familiar. Let's look at another DA, Dumbledore's Army. They used coins for communication, but how do the Harry Potter coins correspond to our money? If we know the conversion factors that were introduced in the wizarding world, 1 galleon is 17 sickles, and 1 sickle is 29 canutes, then we can convert their money into Muggle amounts, where 1 canute is roughly 1.5 cents. So we can convert the amount that Harry made in the Triwizard Tournament, exactly 1,000 galleons, by converting first to sickles, then to canutes, and then to dollars, to find that he made $7,395, which is enough to pay for therapy for watching Cedric Diggory die. Unfortunately, Dumbledore's Army is not real, so let's take a look at some real examples. Let's break down the different types of dimensional analysis. One subset of conversions involves changing the prefix of a unit. The type of measurement and base units are the same. For example, converting from kilometers to meters still measures distance with meters as the base unit, but the prefixes need to change. There are many ways to start problem solving, but dimensional analysis focuses on the units. In this case, a change from kilometers to meters as the guide. We can start by putting the information we know, 15.2 kilometers, into our problem, and we also know that we should end up with units of meters. Since kilo is defined as 10 to the third, this translates that 1 kilometer is equal to 10 to the third meters. Rewriting this in unit symbols, we can then change this to a conversion factor in which the kilometers are in the denominator, so they cancel with the initial kilometers, and the meters are introduced in the numerator. Finally, our answer is 15,200 meters, which can also be written in scientific notation as 1.52 times 10 to the fourth meters. When converting between the same base unit, but with different prefixes, it's often cleaner to convert first to the prefix-free unit and then to the final unit. When finding the number of nanoliters in 25.3 microliters, we know microliter units and can change first to liters, then to nanoliters. Again, listing the information that we know, we have two steps, or two conversion factors. First, micro is defined as 10 to the negative sixth, and we put the microliters in the denominator to cancel. Now we have to convert from liters to nanoliters, so nano is equal to 10 to the negative ninth. We can change this into a conversion factor to make the liters cancel, and we're left with nanoliter units. The answer, 25,300 nanoliters, can also be placed in scientific notation. In other cases, we'll be converting not just prefixes, but entire unit types. Typically, conversions like these involve going from metric units to English or American units, and vice versa. For example, one can express a length in centimeters, which is a metric unit, and convert that to inches, which is an English unit. Or when you're baking or cooking, you may need to convert masses in grams to units of pounds because of our scales. Because there are so many such conversions, you won't need to memorize these conversion factors, but you do need to know how to use these conversion factors when changing units. For example, consider if you run 3.5 miles and call your Canadian friend to describe your new workout regimen. You'd need to translate the 3.5 miles into kilometers for her to appreciate your hard work. Looking at the problem, we can identify the information that we start with, 3.5 miles, and the units we should have at the end, kilometers. We can see in the conversion factor given that 1 mile corresponds to 1.6093 kilometers. We can start by placing our starting measurement, 3.5 miles, and setting up our conversion factor. We need to cancel the unit of miles, so those go into the denominator, and while we introduce kilometers by placing those units into the numerator. The mile units cancel, giving us that 3.5 miles corresponds to 5.6 kilometers. Now your Canadian friend can understand how far you've run, and you can feel good that you've run a larger number of kilometers, even though you've actually still run the same number of miles. As the class progresses, we'll see more complex problems that will require multiple steps for conversion factors, and sometimes formulas that require specific units will also be used. Dimensional analysis can help identify individual conversion factors that can be used one at a time to systematically change units. For example, if we want to convert the Food and Drug Administration's daily recommended allowance of sodium from milligrams to pounds, we can first establish the given conversion factor that 1 gram corresponds or is equal to 0.0022046 pounds, where the symbol for pounds is lowercase lb. Since we start with milligrams and need to end with pounds, it makes sense to map out that we can first go from milligrams to grams, and then use the given conversion factor to convert from grams to pounds. We know that milli stands for 10 to the negative third, so now all of our conversion factors are set. The two steps listed correspond to the two conversion factors that will be used. Starting with 2400 milligrams, we know that milli in the denominator will cancel the milligrams, where 1 milligram is equal to 10 to the negative third grams. We can calculate that 2400 milligrams equals 2.4 grams. In a second step, we can take the 2.4 grams and convert to pounds by making our conversion factor with pounds in the numerator and grams in the denominator. Calculating this tells us that 2.4 grams equals 0.0053 pounds. Note that we can also string conversions together in sequence. Since 2.4 grams is repeated, we can skip the intermediate step and set up two conversion factors back to back. Remember, two conversion steps, two conversion factors.